Chapter 4, Section 3 is where our logarithm functions start. And just as a fair warning, this is probably going to be a two-part video just because this is the longest section in Chapter 3. It's two or three, about 3 pages worth of stuff here. So it's going to, and I really don't want to rush through it because it is kind of the most important thing that we're going to be doing here. So that's why I'm trying my best to make sure that I am thorough, but don't spend too much time on this. Okay, let me explain to you what we use logarithms for, and then I'll start, talking about how to use them. We use a logarithm to solve for an exponential function whose base cannot be changed to match. Okay, so an example of that might be, for example, let's see, if I said to solve 2 to the x plus 4 is equal to 7. And I said, okay, solve for x. Well, there is no way that I can change 7 to have a base of 2. And there's no way that I can change a 2 to have a base of 7. So in situations where your exponential functions, the base cannot be changed to match, then that's where we use logarithms to be able to solve those exponential functions. Okay? And there's 2 different ways that you can look at a logarithm, or there's 2 different ways you can look at an exponent, rather. You can convert expressions and equations from logarithmic form to exponential form, okay? And that's actually what we're going to do here. And I'm going to start with a problem in exponential form. So let's just say I gave you 2 raised to the 3 is equal to 8. Okay, and that's a true statement, by the way. 2 raised to the 3rd power is 8. And I said, okay, I want you to write this, I want you to rewrite this in logarithmic form. Okay, so to do that, you say log of the base number, so whatever the base number is, raised to the answer is equal to the exponent. Okay, now I guess in order to understand where I'm coming from here, let me just label some stuff, okay? I'll do this in blue. 2, this is our base number. Of course, 3 is our exponent. And I called 8 our answer, or our solution, or, just kind of whatever you wanted to call it there. In logarithmic form, I told you it was log base 2 of 8 is equal to 3. So in log form, your base number goes right here. It's a little sub number. The answer to the exponent is going to go right there, or the exponential function. And this is actually where your exponent goes, right there on the end. So that's how you convert between logarithmic and exponential form. Okay? Let's do another one. And I want to do one that's maybe a little more complicated this time. What if I gave you an exponential form, 1/2 raised to the negative 4 was equal to, let's see, 16. All right? So even if it has fractions and it has negatives, it doesn't make a bit of difference, because what we're going to do here is we're just going to rewrite it in logarithmic form using the base, the exponent, and the answer. So this would be log of the base, which is 1/2. Then you put the answer that we had, which was 16, is equal to the exponent. Okay, let's go backwards now. Let's say that I gave you, actually, no, I want to do one more. I'm going to do a bigger one here. So what if I did 10 to the 5th power is equal to 100,000? Okay, so if you wanted to go backwards into logarithmic form, and again, even if the number's large, you still do it the same way. So you would do large, or log. And by the way, I want to make a note of something. If you get a log base 10, that is considered to be a common logarithm. So let me write this right here. Common log is anything with a base of 10. Base 10. So if you get a base 10 like this one, you don't actually have to write it down there at the bottom like I just did. So instead of putting base 10, you could just leave this as log, and by leaving it as log, it's an understood base 10. All right, so log 5 is equal to 100,000. And by the way, in your calculator is already set up to be a common logarithm. So if you just hit the log button in your calculator right now, then it assumes that you're referring to log base 10. All right, let's go backwards now. I want to go the other way. So I'm going to give you a logarithm, and I want you to rewrite it into exponential form. So let's say we have log base 3 of 100, or I'm sorry, not 100, but 1 over 81 is equal to negative 4. Okay, so to go backwards, the base was 3, the exponent is negative 4, and it equaled 1 over 81. All right, let's do another one. Let's say we have log base 5 of 5 is equal to 1. Okay, that's the same thing as saying 5 raised to the first power is equal to 5. And if it's raised to the first power, you don't even have to put the logarithm, or you don't have to put the exponent there. You can just, leave it as 5. Okay, and then one more that I want to do here. Let's do log. Oh no, that just like disappeared. That's crazy. Okay, let me go back. Computer's doing crazy things. I don't know if I like it. There we go. So, log. I misspelled log. We're just going to go with it. Log of 3 over 4, 1 is equal to 0. And I know y'all can't see that very good. I'm sorry. But that would be the same thing as 3 over 4 raised to the 0 power is equal to 1. Okay, so now that we have writing between logarithmic and exponential form, let's try to solve some exponential equations and some logarithm equations using the technique of just rewriting it. Okay, so to solve a logarithmic function or a logarithmic equation, this first step is actually just to rewrite this into the other form. Okay, rewrite. And in this case, we're going to rewrite this into exponential form since it's already written in logarithmic form. Okay, so to rewrite this, we know that the base in this case is x. We know that the exponent is going to be 3, and we know that the answer is going to be 8 over 27. So the base is x, the exponent is 3, and the answer was 8 over 27. Okay, and once you rewrite it, it looks more feasible to solve it, right? So step 2 is actually now to just solve for x. So if we're going to solve for x here, and it's x raised to the third power, how do you get rid of something raised to the third power? Well, you cube root it. And so we're going to cube root both sides here, and we're going to end up with 8, or we're going to end up with x is equal to the cube root of 8, which is 2, and the cube root of 27, which is 3. And I have no idea why that keeps disappearing. That's crazy. There we go. But you're going to get x is equal to 2 over 3. Okay, let's try another one. And we're going to do the same thing here. We're going to rewrite this in exponential form, and then we're going to solve. So to rewrite this, we're going to say base of the exponent, which is 5 over 2, is equal to x. Well, that's actually really simple because now you can just re-put this into the calculator. Hopefully you remember from, I think, section 1, how to write an exponent that has a fraction, or how to write this as a, to rewrite this as a radical. This is actually the same thing as the square root of 4 to the 5th power, which turns out to just simply be 32. So the answer is 32. Okay, let's do this one. So to rewrite this, you would say 49 raised to the x power is equal to the cubed root of 7. All right, so in this particular problem, it didn't really help us to rewrite this whatsoever because, we're not going to be able to solve for the x unless we can, again, change the base on this so that we have a common base. And I'm looking at the 49 and the 7, and what I notice is that 49 raised to the, or I'm sorry, 7 raised to the second power, 7 squared, is actually the same thing as 49. So I can change that 49 to have a base of 7, okay? And then right here, this one, I can rewrite this as 7 raised to the 1/3 power, because radicals can be rewritten as a fractional exponent. So just to recap what we just did, if you rewrite a logarithm into exponential form, but then you can't necessarily solve it yet, then you may have to also do change of base along with that. And it's, you know, and when I say change of base, I meant like the same base, change it into the same base. But now, from section 2, we know if we do have similar bases, and let me just clean this up a little bit. This is going to be 2x equals 7 to the 1/3. If we do have the same bases, then we can just set the exponents equal to each other. So in this case, we would say 2x is equal to 1/3 and solve. So 2x is equal to 1/3. And then if I multiply both sides by 3, well, that's actually not going to give us what we need. We need to divide both sides by 2. So if you divide both sides by 2, then you're going to get that x is equal to 1/3 divided by 2. That's the same thing. Yep, it's going to be x is equal to 1/6. All right, I'm going to stop right there. We'll talk about properties in the next video.